All right, so welcome to the second episode of our podcast series, Generative AI in the Real World. Today, I'm with my good friend Pete Warden. He is the founder of Useful Sensors. He's also the author of an O'Reilly book called TinyML. So, welcome to the podcast, Pete.
Thanks so much, Ben.
And for our audience, useful sensors. I went to their website and I grabbed a couple of things on their website to describe them, but I'll obviously have Pete describe it as well. But useful sensors is AI you can trust. We make interfacing with machines, everyday appliances, and electronic devices as easy as communicating with another human. So, with that said, Pete, please introduce useful sensors. And so, what does the company do, and what is your vision?
Yeah, so what you said really describes it well, that we're trying to make it so that you can interact with appliances, consumer electronics, TVs, refrigerators, as easily as you can interact with another person. And so what that means in practice is, for example, we've built this little person sensor module that has a microcontroller and a camera built in and runs pre-built machine learning models to tell you, for example, hey, is there a person there? How many people are there? And whether they're facing the camera. And really the idea is we want to enable things like I really want to be able to look at a lamp, say on, and have the light come on. Or I want my TV to automatically pause when I get up to make a cup of tea without me having to find the remote. And so in order to do that, we're building these capabilities like the person detection, like doing speech to text on the edge. So being able to do full Alexa style voice interfaces without any kind of network connection and in a very privacy focused way as well.
So, you were one of the people who coined the term TinyML, and you even wrote a book about TinyML. So now I think we're entering what can be described as sensor-driven AI. So, what are some of the challenges with this, I guess, emerging category, and what are some of the more interesting use cases?
So a big challenge with TinyML overall is that it's really been picked up by a lot of technologists, but it's not made its way into real products. So a lot of this current wave of stuff that's happening is really around, okay, we've got this technology of running machine learning on these tiny 50-cent chips. What can we actually do with it that's practical? And some of the things that I'm really excited by are actually pretty simple. Like if you think about outdoor security lights, just being able to have them only turn on when there's a person there versus turning on when there's like wildlife or trees moving or other stuff like that, that not only makes them more useful in terms of actually letting you know if somebody's in your backyard when you weren't expecting them, it also saves energy and hopefully will annoy your neighbors less with the light just going off all the time. So what I'm really excited about is bringing a lot of this very sort of abstract AI technology into real world applications like that.
So, Pete, is this category more specific to people who work in hardware sectors or hardware industries? So, in other words, if I'm in a bank or some sort of enterprise, is this not something I should care about?
So even in banks and other places like that, we've seen, for example, factories where they need to know if somebody's in an area that should be a clean room or where there might be a danger of machinery. kind of, interacting with somebody. Or, in the bank case, I know from my Google experience that we had motion activated lights in our conference rooms. So if we were in a really boring meeting and nobody was moving, then the lights would go off and we'd have to stand up and sort of start waving our arms. So even in traditional industries like offices and banks and things like that, there are a bunch of interesting potential use cases for this kind of technology.
So for our listeners who may not know, just to kind of add to Pete's gravitas here. So Pete was one of the creators of TensorFlow and one of the creators of TensorFlow Lite. But even before then, he was one of the early users of Caffe, one of the earlier deep learning frameworks back when you had to compile the stuff in C++, and it was a real pain to use Caffe. But I say this because a lot of what Pete used to work in the past was computer vision, because that's how deep learning became popular, was computer vision. And as you know, Pete, right now, the rage is these language models, LLMs. You talked about speech, right? So speech was also, just like computer vision helped deep learning become mainstream. I think people forget how important speech was in terms of changing people's minds about deep learning. But now we're in this age of foundation models and large language models. So the word large is there. So Pete, by definition, doesn't this collide with tiny?
Well, I've actually been seeing a bunch of people doing tiny large language models, which I love. I love that term. And we've had things like Mobile BERT, which, can get down to sort of 10, 15 megabytes, based on the original transformer sort of, BERT architecture. So even though large language models, it sounds like they must be enormous, typically they're on the order of, gigabytes, which, if you think about a phone having a 3 gigabyte model, which is on the smaller end for some of the large language models, but that isn't actually that massive. It's not going to blow out your storage. Even having a 70 gigabyte model, that's large in terms of language models, but it's not actually that crazy if you think about the compute and storage that we all carry around in our pockets. So I think people sometimes get thrown by the large in the large language model by thinking that it's something that can only run on data centers, whereas in fact the compute that we have available on the edge these days is very capable of running these kinds of models.
So in your experience, Pete, looking back to the lessons in computer vision, right? So where people worked a lot on things like sparsification, quantization, and things like that. Do you anticipate that there will be developments in this sensor-driven AI, this TinyML community, that will benefit the much broader LLM community?
I'm already seeing, actually, at the moment, we're very much the recipients of a lot of work that's happening on the within the LLM community around, for example, quantization. That used to be a very niche subject, a niche research area that only people who were deploying, either very compute intensive applications to a lot of different machines or were deploying to the edge actually cared about. Now, because people are trying to run these large language models, and they're running out of memory, even on things like fairly good GPUs, looking at quantization has become a very popular research topic amongst a lot of people around LLMs. So I think in a lot of ways, we're actually benefiting from all of the activity and research that's happening around quantization and sparsity and pruning and distillation and everything else.
So in the areas where useful sensors operate. So, can you give us a sense of what's possible today, what's deployable today in all these areas? Computer vision, speech, and language.
So a lot of what we're doing is trying to make sure that we can actually run some of these advanced capabilities on the kind of really constrained, cost constrained, size constrained, power constrained hardware that goes into mass volume consumer electronics. Um, so one way I kind of think about it is a lot of the stuff that was maybe cutting edge, like 8 years ago in the computer vision world, is now starting to become possible on these 50-cent chips. So we can run person detection, face detection, face recognition on an RP2040. That in volume is probably around 50 cents per chip, even though it only has 400 kilobytes, or sorry, 300 kilobytes of memory, and a dual core Cortex M0. We've actually been able to run these kinds of advanced computer vision use cases on that. And for the speech side, we're able to do full speech to text on hardware that's in the sort of $5 range. So that's something new that really wasn't possible up until sort of a year or two ago.
So, for the product designers who are listening to this conversation, how should they think about these capabilities? Is it more like I can pick and choose and assemble different capabilities? In other words, based on what you've described, a lot of these things are single task, single purpose, right?
Exactly. Like one thing I found to be helpful is the reason we called our company Useful Sensors is because a sensor is a really nice abstraction for providing a capability. So, for example, a lot of the people who are buying our person detectors, our person sensors, they aren't interested in machine learning at all. They just want a better passive infrared sensor. Like I was talking about with the security lights use case, they want something that's only going to trigger when a person enters a room and not just on random movement, and that will stay on even if the person isn't moving. So what we're trying to do is add some core capabilities to product designers' palette, and uh, make it so you don't have to think about the machine learning that's underlying this.
So let's make this concrete and let's talk about one of your first offerings, which is called AI in a box, right? So something that I sadly still don't have a copy of, Pete.
I'll drop one off. I know you live nearby, so
Uh, but okay. So AI in a box. Walk us through quickly from the conception to the actual the reception of the people who have used it, right? So
so the thinking behind AI in a box was we really wanted to showcase how much is possible on a comparatively cheap, low cost processor with no network connection, and how many helpful things you can actually do using AI. So the first thing it does is it listens to a built-in microphone, and it provides real-time closed captions uh, across a whole variety of languages. So you can set which language you want to listen in. So we've had people who are hearing impaired actually experiment with using this to um, actually get closed captions for real life. Or we've used it at events like the recent AI conference just last year, providing captions to talks. So that's been really good showing that off. We've also actually included a local LLM that you can talk to and that will talk back. Again, all running entirely with no network connection. And we've also integrated some open source language translation work. So we're actually able to do spoken translation to and from a whole bunch of different languages. So really, this is a showcase for the capabilities that people don't realize they could have on these on-device edge systems with no network and with complete privacy.
And in keeping with the title of this podcast, this product was designed to work in the real world in the following important sense, which is in the real world, there's a lot of ambient noise. And so I can attest that when Pete and I first, when he first showed me this product, we were in a very loud coffee shop and it worked like a charm. And at the AI conference, for some reason, we mistakenly placed them next to the DJ, and it was still amazingly accurate. This AI in a box. So, quick question about not having network connection, right? So, as you know, having been in this deep learning AI space for many years, things move at lightning speed, right? So surely whatever is AI in the box model has needs to be updated now and then, correct?
So that's a good question, and it really depends. Like if you have something that's working well enough, providing closed captions for your purposes, it's not obvious that it needs to be updated frequently. We also actually allow you to, there's an SD card that you can potentially update. We've open sourced all the software behind this AI in a box, so people can, update it themselves if they want to. But you'd actually be surprised. A lot of engineers really get caught up on the idea that you can't update it. But there's a whole bunch of use cases where if something is working well enough, it's actually better not to touch it and not to risk kind of destabilizing it and not to have that attack surface in terms of, oh, there's an update service that could be hacked, maybe 10 years down the line, and the manufacturer is no longer providing support for the device or whatever. So that's actually one of my opinionated positions on this. Is I really wanted to avoid even allowing updates over the air because it actually provides some nice properties for the product.
So, as I mentioned at the start of this episode, in your website, you call out everyday appliances and electronic devices. And as much as we talk about smart appliances, even appliances that you buy these days are not necessarily things that are designed to be updated regularly, correct?
Yeah, and a good example of that is one of the areas where we see a lot of interest is in actually providing talking user manuals for appliances. So you can walk up to your fridge and kind of ask it, hey, why is the icebox not working? And essentially what that's doing is querying the user manual. And you might think, oh, what if the user manual changes? What if that's updated? Well, the way that most people get their information is actually from a paper user manual, which is not updated. And manufacturers don't actually tend to update their information once an appliance is shipped. So that's an example where we're not losing anything by just shipping this offline version. And it means that it's way easier to set up. Like less than 30% of smart appliances ever get connected to Wi-Fi, according to the people we talk to.
Yeah, and this is actually an important point. I think sometimes we are a captive of over designing and designing for perfection, but as Pete mentions, you have to design for reality, right? So that example you gave is super interesting of walking up to something and asking for help. To me, this harkens of like a on-device retrieval augmented generation.
And that's actually an interesting point because um, often RAG comes up when we talk about this, but the manufacturers we're talking to, they don't want any generation at all.
Yeah.
They really just want extraction. So it turns from a retrieval augmented generation into a neural search where you try and match up the question with a sort of known question in the manual, and then um, make sure that that vetted answer always is given, so that manufacturers worry about people being told to stick a fork in the power outlet or something if they ask the wrong question.
So
So
hallucination is a fatal bug.
exactly. And even if it's not hallucination, if it's like, you ask it like, oh, what's the best dishwasher manufacturer, and it's a Bosch machine and it says Whirlpool, like, that may be factually correct according to some ranking that it's picked up off the web, but that's also not something that a manufacturer would want their um, device actually saying.
So the nature of the things you work on, Pete, right now, the interface is voice, correct?
So it's usually a combination of voice and presence. So, the example of looking at a lamp and saying on, like looking at it and that gaze detection is actually like the wake word that you would normally use with something like Alexa or Siri, but instead of that it's just the attention. So we have to use computer vision for that part, and then speech recognition. But even with speech recognition, we might be using computer vision to tell that it's you talking, and maybe even do some lip reading in a noisy environment. So um, it is correct that the voice interface is at the center of a lot of this, but it's all around having that awareness, like people have awareness of the person who's talking to you, and getting information from as many channels as possible.
And so what are some of the very, very specific challenges in the arenas you operate in? I suspect, power consumption is one. How about latency and real time, right?
Often we're aiming for the mass market. We're aiming for hundreds of thousands and millions and tens of millions of units sold. So that means that cost is a massive constraint. And usually that means we have to trade off things like latency, or capabilities or features, to hit that cost target. So a lot of it is really trying to figure out what's acceptable for different applications and what trade-offs are actually okay. And like you mentioned about power, there's no uh, we don't aim at battery powered stuff right now. We're looking at entirely mains powered, because of the having that constraint on top of everything else would just make things way too hard.
So we briefly touched on large language models. So what is the future of large language models in the useful sensors world?
So coming back to that idea of extraction, um, I really see a lot of applications where generation is not acceptable for, but being able to use the other capabilities of actually understanding natural language. Um, so, for example, a similar use case to the talking user manuals is I want to be able to walk into like a home improvement store and walk up to a box on a pillar and ask it like, where's the PVC piping, and have it send me in the right direction. And that's another example of that kind of extraction use case. So we're actually doing a bunch of research and work around, okay, how can we kind of formalize this, not even RAG, but pure extraction capability on top of a large language model type infrastructure? Like, does it just look like some kind of neural search where you're just matching vector embeddings of a natural language question against a known canonical list of questions that you know the answers to, or like how does it look? But it feels like that's an under researched area because everyone's really focused on generation right now, and I'm hoping that we can make some contributions there.
So you assume everything is on device, happens on device?
For our applications, yes. I mean, we do work with appliance manufacturers, for example, who want to help people connect to Wi-Fi, but using our on-device voice interface. If you think about something like a consumer home modem for Wi-Fi, like that isn't connected to the internet when you're starting to set it up, and it can't be so being able to provide a voice interface before it's set up can actually help increase the amount of internet usage. And we don't see them as kind of the on-device from taking away from internet usage. Like we can do on-device stuff and still have an internet connection. It's just really nice because it works as soon as you plug it in.
So on device is great for privacy. Obviously, if nothing is getting uploaded to the cloud and there's no federated learning happening, unless the data is stored on device and someone steals the device somehow.
Yeah, and that's one of the things that we're working on. Like with the person detector, we make sure that nobody can get access to the underlying images because they're what's really sensitive. With speech to text, it's a little bit different because the kind of text itself that comes out is actually the sensitive bit. So one of the things we're looking at doing is if we can design hardware modules where the manufacturer only specifies the model that answers the questions, and there's never phrases which trigger actions, and all the rest of the system gets to know about is kind of have those actions being triggered versus being able to listen, have a stream of all the spoken text kind of available, because that's a more challenging privacy application for sure.
So on the security front, the good news for our listeners is Pete and his team write a lot of their own software, including their own deep learning framework to do these things. On the other hand, they may not have kind of the problems that we have as far as the Python software supply chain, but there is still things like firmware, Pete, that you have no control over, right? So walk us through some of the security concerns and what are you doing about it?
So one of the founding principles of what we're doing is that we want our stuff to be checkable by third parties. When I was at Google working on speech, I often had friends and family who would say, I was just talking to a friend about Tunisia, and then I've just started getting all of these ads for holidays in Tunisia. Like, what the hell, Pete? Are you spying on me? And my response was like, no, I wrote some of that code. I know that we're not, but I can't prove it. So a lot of what we're trying to do with Useful is create systems that can be checked by third parties. I would love to have underwriters laboratories and consumer reports and other people be able to actually give the thumbs up in terms of, yes, we've been able to check this module and these are the only things that it's actually able to output.
So I recently read a post of yours on a subject called dark compute, a term that Pete is trying to memify, I think.
Well, I just love the idea because it makes us sound like supervillains or something. Let's use the dark compute.
So, tell our listeners at a high level what dark compute is and why is it important, and why should they care?
So if you're old like me and Ben, you might remember the .com bust, and what that left in its wake was a bunch of fiber optic cable that was not being used, and so that was known as dark fiber. And what we have right now is we have microcontrollers in all of these everyday objects, and even sort of SoC type things in fridges and audio and TVs and appliances. And because of economic reasons, they are almost always over provisioned with compute. So they have a lot more compute than they're actually utilizing, at least, on average over most of the time. And so I did some calculations, and even being fairly conservative, the amount of idle compute that's sitting out there in all our devices is more than twice as much as all of the world's GPUs combined. Um, so that really is one of the foundations, one of the things that we see in the world where we think we can use AI to actually turn that unused compute into something useful.
And I think the evidence that it can be turned useful is what you're doing at Useful Sensors. I think for listeners who don't follow the space closely, the kind of the high level knowledge of users is that the only way to do this is on GPUs, specifically NVIDIA GPUs. But what Pete and his team and others are proving out is that no, you can actually get a lot done on CPUs and even sensors, right?
Exactly.
Yeah, and so Pete, in closing, so what do you see are the biggest opportunities for pushing AI, generative AI, into consumer devices and sensors over the next few years?
So I really think we have to start from problems that users care about. One of the classic things that I really don't like the term IoT for many reasons, but a lot of it was because it was very much driven by, hey, we've got this technology, what can we use it for? I think we have to start with problems that users care about. Like, a classic example is an IoT connected dishwasher. Um, we really struggled to find any use cases for why you would want your dishwasher connected to the internet. Like, they didn't seem to, but people are still doing things like that rather than starting from, hey, let's connect to the internet and then figure out what we need to do. We're trying to start from, hey, what do users care about? They care about their devices breaking. So can we fix that? They care about things like how long their TV takes to start up when you press the on button. Like, because they're all running Android effectively, it can often take 10 seconds or more. So if we can help pre-boot TVs, that might actually be very helpful. And really just trying to come up with stuff that makes it even just a small difference in people's everyday lives and start from there.
And listeners, you can follow what Pete and his team are doing at usefulsensors.com. But Pete, for people who want to plug in, I mean, I'm sure there's you guys are hiring and they can try to apply for jobs at Useful Sensors. But if people who want to try to plug into this broader movement around TinyML and sensor-driven AI, what are some ways they can do that?
So my favorite starting point is the TinyML Foundation, which Evgeny Youssef from Qualcomm set up. I've been helping out with. If you go to tinyml.org, you can actually find a lot of meetup groups. You can find a whole bunch of resources. And there are also, if you look up TinyML on edX, you can find a free course that we put together with Harvard. It doesn't look like it's free because they try and make you register, but you can actually take it for free as long as you don't mind not getting a certificate at the end. So,
And with that, thank you, Pete. And again, listeners, go to usefulsensors.com. And as Pete mentioned, this is a space where you can truly make a difference in lives.